A driving instructor gives a student a sudden order to stop the car in the shortest possible time. The figure shows the speed time graph of the motion of the car from the moment the order is given. So we see the car is moving at 18 and is being told to stop right now, but there's a 0.9 second delay when the brake is activated and the car slows down gradually with a constant deceleration. Why is there a delay? Well, it's very likely it's a reaction time. Let's try to tackle the first part of the question. The order to stop is given at time equals to 0, states the speed of the car at 0 seconds. So we've already kind of figured it out. It is 18. So let's write that down. Now it's very important to say 18 meter per second, right? The units are very important. Sometimes they'll give it part of the question, other times they won't, and you have to write it down. So that's very important. So just why the car continues to travel at the speed for 9.9 seconds. So you can explain it, but the simplest explanation is that it is reaction time. And that's good enough. Calculate the deceleration of the car at t equals to 0.9, which is when the brake was initiated, and t equals to 4. So if we take a closer look at the graph, that's when the car is slowing down, right? So this is 0.9 seconds. So what is the speed over here? Well, it's tough to write over here, so I'll highlight it here. It's 18. That's the initial velocity, right? Because it was the velocity before the braking happened, or at the start of our time, which is, so here, which is 0.9. And at the very end, the velocity is 0. That's our final velocity. So it's easy as putting it into the equation. So let's try doing that. Our formula is the acceleration is equals to the final velocity minus the initial velocity divided by the total time taken. The final velocity is 0 minus the initial velocity, which is 18. Divide that by, struggling for space, but divide that by the time, which is 3.1 seconds. That's the difference between 0.4 and 0.9. And putting it in the calculator, it should come out to, well, negative 5.8. But the question is already has highlighted that it is some form of deceleration. So you don't need to put the negative sign. So it's going to be 5.8, but it's going to be meter per second squared. So in the second part, they're asking us the total distance traveled by the car from t equals to 0. So what's interesting is that the car travels unbraked for this period for 0.9 seconds, and it's 18. So essentially the area of this graph is going to tell you the distance traveled over here, and the area traveled by this triangle on the side will tell you, right? So let's get dimensions out. We already have the dimensions of this rectangle. Let's get the dimensions out of the triangle. Now you need to understand the height of this triangle, of course, is still 18. It's kind of hard to see. That's 18. And this length is 4, and over here it is 0.9. The difference of time from here to here, we already calculated it, is 3.1. So the base of this triangle is 3.1. I hope that makes sense to everyone. So let's try going back. All right, let's see if we can try to put in the values. So the total distance covered is area 1 plus the area 2, right? Area 1 is the rectangle, and has dimensions 18 times 0.9. Area 2 is a triangle, so I'll use the triangle formula. That is, the base is 3.1 if I recall correctly, and the height is again 18. Solving that, your value should come out to be 44.1 meters. Again, don't forget the units. That's important. All right. Question number 2 is asking that a bus travels at a constant speed, it stops for a short time and then travels at a higher constant speed. Using the axis in figure 1.1, draw a distance time graph of this bus's journey. Well, the bus is traveling at constant speed. This is distance. Distance is going to increase at a constant rate. So to the best of my ability, I'd use a scale. Increasing constantly, then it stops for a brief period. So if it's stopping, not moving, the distance won't be changing for that amount of time. So it'll look like this. And after that, what's interesting is that, where is it? The travels at a higher constant speed. So it's traveling much faster. So the distance for the same time should increase a lot more. So the graph should be a little steeper. I'm making it a lot more exaggerated than required because this is essentially what the examiner wants. I know what they want just by reading the question, and I'm making it easier for them. So yeah, and I hope you understand the gradient of a distance time graph is its rate of change, which is velocity or speed. You see it's lower here, it's higher here. Let's move on. A lift starts from rest on ground floor of a building. The speed time graph of the motion of this lift, the top of the floor of the building. Okay. This is the graph. And the question is asking what is the total distance traveled of this with this lift. So that's not too hard. The only challenging part over here is getting the values right. So understand that we want to get this value out. This is corresponds to this part of the graph, which is here. So what is this value? Well, this starts from 0, goes all the way up to 5. And this length from this time, 5 seconds, is divided into 10 equal little tiny squares. So each square should be 0.5. So I'll write 0.5 over here. It's 0.5. So how much time is this from 5 to this dash over here? Well, if I count, there will be 5 squares. So that's 0.5 times, not 2. I was going to write 2 for some reason. It's 5. That's 2.5. So this distance or this length or this time actually is 2.5. So if you're starting from 5, an additional 2.5 means you're at 7.5 seconds, right? So the value over here for this is 7.5, and the height is actually over here, it's 3.3, right? It is 3.3. That's not an issue. Okay. From here, you're at 7.5, and you figure it out. You're ending at 20. So what's the difference from 7.5 to 20? This length is actually is 12.5. From here all the way up till here, like that. And the last is just 5, right? So this length is just 5. And the height for all of these is 3.3. So let's see if we can figure out the area. So we've identified 3 triangles, sorry, 3 shapes, 3 areas. Area 1, which is a triangle. So I'll put a small triangle over here. The triangle on the left. Then there's area rectangle and area triangle again, just to make it a little more visually appealing to my senses. Okay. So area 1 is going to be a triangle, and I recall that the base is 7.5 and the height is 3.3. Rectangle 2, well, that's base times height. The base is 12.5 and the height is again 3.3. And triangle 3 is half times 5. The base was 5, the height was 3 asharia 3. Right? Straightforward. And let's calculate these individual values. They'll come out to be 12.375 plus 41.25 plus 8.25. 61.875. We're not taking care of significant figures right now because we just want to practice how to do the question. So let's focus on calculation rather than what quality of answer. Just put in the answer, whatever you're getting. And of course, the most important thing we're forgetting is that the value is meters. All right, I hope we're gaining confidence. Question number 3 shows a skier taking part in a speed competition. The winner of the competition has the highest average speed over a 100-meter section shown. Okay, so he's falling, he really tries to accelerate, and at this point they try to measure that what's the fastest speed during this period before they stop. That's cool. They give them some time to accelerate, to do the best they can. The skier starts from rest and has a constant acceleration. He reaches a speed of 60 meters per second in 16 seconds. So at some point after 16 seconds, his velocity is at 60 meters. So let's figure out what the question's trying to ask us or is going to ask us. Right. So what they're trying to ask us is pretty straightforward. They're trying to ask, the skier starts, well, we know this, calculate the skier's acceleration. Well, that's as simple as knowing that the acceleration is v minus u over t. Well, he started from rest, so his initial velocity is going to be 0. His final velocity is 60. Divide that by 16 because that happened in 16 seconds, right? And you should get 3.75. Yeah. And its acceleration, the units are meter per second square. Now, this part is done. Over the length of the 100-meter section, the time recorded is 1.85. So he goes through it. Sure, he's still accelerating, so we don't know what's going on. So in those 100 meters, he takes 1.87 seconds to cross. So calculate the skier's average speed over this section. So average speed is pretty easy. Average speed is going to be the total distance traveled over the total time taken. So the total distance is pretty easy, 100 meters in 1.85 seconds, and that should give us 54.05 meter per second. Again, the units of average speed, because it's still speed, will remain the same. So our last part is interesting because we haven't talked too much about it, but we have an idea because we neglected this aspect when we were checking free fall. Suggest why the skier bends his body as shown in the figure. So he's bending down to minimize his surface area exposed to the wind that's hitting him, which is going to slow us down. So essentially he's trying to fight air resistance. So his goal is to minimize air resistance is good enough. This is an interesting question. An astronaut on the moon drops a feather from rest off the top of a small cliff. The acceleration due to gravity on the moon is 1.6 meter per second square. There is no air on the moon. The feather falls for 4.5 seconds before it hits the ground. So it travels for 4.5 seconds. So draw a speed time graph of the falling feather. So, well, if I figure out what the speed is at 4.5 seconds, I can make a very nice straight line. So why not just use the acceleration formula to find the velocity at that time. So acceleration is v minus u over t. Putting in the values, 1.6 equals to final velocity. I need to find out. Initial velocity is 0, so I won't write that down. And how much time? 4.5 seconds. Right? And I'll get this value as 7.2 meter per second, because I'm trying to find out v. That's the final velocity. So at 4 over here, 4.5, the height, the value is 7.2. So that's the value right here. Right here. Right? So I need to connect these two lines, so let me try that. I meant to say points. Let's try doing that. Alright, it's going to start from 0, go all the way up to 4.5. And at this point, it hits the ground and stops moving. So in a very small instance in time, it goes over a very strong deceleration. So essentially, it's going to be here till here. And the motion then stops for this feather, right? Okay, let's try taking care of the next part. All right. Determine the distance fallen by the feather. Well, if we had a graph, it would be very useful, and we do have a graph. So the height of the graph, or the area of the graph, is telling me the distance traveled, because it's a speed time graph. So the distance traveled is essentially the area, which is half times the distance, the time taken, which is 4.5, and the maximum velocity is 7.2. I should get 16.2 meters for this. So part B, sketch the shape of the speed time graph if the same feather falls on Earth. Sure, no problem. The only thing is, when it's falling on Earth, they distinctly said on the moon there is no air resistance. On Earth there is air resistance. So they're not too worried about the speed attained at a certain time, because they're not giving us values. They're looking at the curve or the shape of the graph, right? So when it starts off, a feather or a ball, anything, will have a very steep, gradient, because when something is slow, it just starts moving. There's no air resistance. But air resistance, the faster you're going, the more air resistance there is. So over time, what's going to happen is the curve will get flatter and flatter and flatter. So essentially, it will be a curve that should be shaped a lot like this. Explain the difference between speed and velocity, including words, vector, and scalar in your answer. Well, the bane of any O-level student's existence, this question. Well, a speed is a scalar quantity, only has magnitude, as it only has magnitude, whereas a vector sorry, not a vector. Velocity is a vector as it has both magnitude and direction.